Concrete design, how you calculate the minimum reinforcement, AS minimum? For a reinforced concrete beam according to the ACI code, how you calculate AS minimum? Or yeah, if you take it BWD on the other side, it will become rho minimum. So this rho minimum is what? You can see here it is 0.03 Fc prime over Fy for a bridge according to AASHTO. And what is this ASK? This is a skin reinforcement. You know, if the depth of the girder increases by 900 mm, we need some skin reinforcement to control the shrinkage. What is skin reinforcement? If you have a very deep girder, this girder depth, let's suppose the depth of this girder is 1300 mm, for example. Now, where do you provide the tension steel? Where do you provide? At the bottom. And here you provide the compression steel. But what about this side? Do you provide any steel? Yes, there is a shear. Shear stirrup. We provide shear stirrups like this. But here, in the longitudinal direction, we provide some steel to control the shrinkage. And this steel in the longitudinal direction, the stirrups are like this. Like this. But we provide the steel in the longitudinal direction along the depth, and that reinforcement is known as skin reinforcement. That reinforcement is known as skin reinforcement. And how we calculate this skin reinforcement? By this formula.
There is the standard value for the depth to compare if it is depth or not.
If it is?
If it is very deep or not.
900. It is written here. If it is more than 900, then you have to provide the skin reinforcement. Please read this. Please read this paragraph. Please. And you also get the maximum spacing of the DE is the effective depth. Okay. Now, have you studied T-beams?
Yes.
So how to calculate the effective width of a T-beam?
There is
Some formula.
I think three formula.
Number 1,
Four.
L over 4. Number 2, in case of concrete beam, it is 16 HF.
Yes, we studied 16.
16 HF plus BW. But for a bridge girder, it is 12. Plus BW is the width of well, or the bottom of the beam. This is for interior beam. And what is S? S is the spacing of beam. For example, after how much spacing we have the beams? This is S.
Span or?
Spacing, not the span. And this is BW. And this thickness of slab is basically HF. So this is how we calculate the effective width, this width of a T-beam girder. it will be the lesser of these three. In case of interior beam and in case of exterior beam, this is an exterior beam.
This is called LB.
Yes. For exterior beam, it should be this width should be lesser of 1, 2, 3. In this class, we are dealing with the design aspects. Today, we are talking about the design aspects. In the previous class, we discussed about the loading aspects. Okay. So these are all design aspects, and I hope you have studied the design of T-beam in reinforced concrete. Have you studied the design of T-beam?
Yes.
Doubly?
Yes.
Doubly reinforced beams.
Yes. With you.
No?
I think
No.
that's
Continuous beams?
Yes.
We take one example.
Okay. I don't comment anything. But it is a part of your course. Okay, slab bridge. So, what's the time? Yeah, we have some time because next is it working or?
Yes.
Okay, next is a slab bridge. What is a slab bridge?
Above the
Above the bearing.
There are different types of bridges. The slab bridge is the most basic type of a concrete bridge. For example, this is your road. Okay, I'm showing cross section. There is one small channel. Okay, going like this. So on this channel, what you do, you provide a slab. And you make a bridge. Do you understand?
Yes.
So this type of bridge is known as
What's the best?
this is, for example, instead of providing big girders, why don't you provide just the full slab? And this, but we have a range. This is the most basic type of a bridge, and I told you it ranges from 6 to 10 meter. You cannot go beyond 10 meter.
Even if you provide a column in the middle.
Sometimes we do, but there is no need. Because if you have to provide a column, for example, for 6 to 10 meter, we can provide just one slab. Like for this much span, this is 6 meter. So what do you think? You will provide big girders here? Do you understand?
Yeah.
So why don't you provide just a simple slab and bridge the gap? Fill the gap. So this is the most basic type of bridge. Why? Because now on this slab, you know, the wheels will be passing, the truck will be passing, everything will be passing on these. Will be passing on this slab. So this is the first example, the most basic and simple example of a bridge design, and this example we are now going to study. Okay, and this is the first type of bridge which we are going to study, that is a slab bridge. This is the most basic type of a reinforced concrete bridge. Okay, so let's discuss more about this. Any question about slab bridge? Any question? Just let me have a quick review of all these things. Yes. So we will do one example, and now I give you a choice. either to explain you first all these things and then do the example, or tell you with the example all these things.
During the example, I think it's good to know.
Okay.
What's the
So then I will not discuss in detail, but I will tell you what are the edge support and live load strip width. Okay, I just stopped my class here because this is a new component and I don't want to do in the rush. So now next is this slab bridge. I will make a good example for. I have one example for this. This bridge maybe you will not design for in the real scenarios or in real cases. But why I'm teaching this bridge? It is just like a basic type of bridge, and we will go from very small to the different high types of the bridges. It is just like the design of a simply supported rectangular beam, the most basic type of a beam. So after this we go to the doubly and then T and then like that. So this is the same concept. The slab bridge, the purpose of including this in your course, that we will start with a very basic type of a bridge and then we will go to the most complicated types of bridges like box girder bridge. Okay. Any question? Any comment? No? Okay. How are you feeling about this course? What are your feelings till now?
Too much information.
Too much information?
Yes.
Because it's related to the slab and to the girder to the. It's okay.
Same reinforced concrete design. And what do you think? Reinforced concrete design was a difficult course or not from you three guys?
camera is working, Doctor.
Sorry?
Camera is working. I will not say anything.
Okay, just stop it. Reinforced concrete design, I think it's an easier course. It's easier. For example, I taught this course, and the same way the bridge design is not difficult. There are too many things, but you have to understand what is it. You don't have to remember anything. Okay, I will not suggest you to remember any equation, or like me. I don't remember. I remember all the equations for most of the equations for reinforced concrete design and some of the equations for bridges. But I will not recommend you because I wasted a lot of my time and energy preparing these equations. Or I used it so many times. Now I remember. For example, now if you say you want to design a very small thing, any design component of a steel, or for example for torsion, for shear, because I used so many times that now I remember. The same thing will be with you. Once you will be in the design office, you will be working with the companies, you will use so many times that it will be in your mind. Okay?
Yeah.
But if you just do what you have done with your other courses, you will forget. But this course is a good course. I hope you will enjoy it. Okay, thank you for your time.